Hi students, in the second video for online lecture 3, we are now going to talk about the periodic table and how to find our elements. So this is the modern periodic table. The nice part about this is that we have a very systematic way of organizing our periodic table. First off, you will notice that the atomic number increases in order. We start with hydrogen in the upper left-hand corner, going to helium, and then we go to lithium, beryllium, and so on and so forth. So as you see in the periodic table, we are going to have our number of protons be the way that we organize our elements. So then you will also notice that our masses are located below that in our periodic table symbols. These are the masses that we expect you to use when you are doing calculations for stoichiometry. So, what else do we need to know from the periodic table? You have to be able to find elements very quickly. Some elements have symbols that differ greatly from their names. This is because they either use Greek roots, Germanic roots, or other languages that we have used when the elements were identified. So we would use different symbols, and then we have translated that to the English language over time. You need to know where all of these elements are. Now, you will not need to memorize this. However, you will be given a periodic table for all exams, and finding elements quickly can save you a lot of time, especially when doing advanced calculations. So let us go and look at some of the terminology. The horizontal rows of the periodic table are called periods, very much like that of the time division in hockey. A period means a group of elements that have the same number of electronic levels. We are going to talk about that once we get into further chapters. If we look at groups, that is the vertical column. These are elements that have similar properties. So when dealing with this, we can look at our groups and we would expect them to have similar chemistry, and you will see that that comes from the typical number of valence electrons as we're starting to go through our electronic properties in later classes. The first group of note is the alkali metal. The alkali metals are in group 1. These are the atoms of lithium, sodium, potassium, rubidium, cesium, and francium, and these are very highly reactive metals that you will see form many salts that we are going to deal with in our semester. The next group is typically called the alkaline earth metals. These metals, such as magnesium, calcium, strontium, barium, and radium, are very good metals that will typically form +2 ions, and you will see them in great detail in many of the ionic compounds we will see in later chapters. Finally, let's go to the halogens. The halogens are going to be our fluorine, chlorine, bromine, and iodine located what is in group 7A. So it's very important that you see that the halogens start with fluorine, chlorine, bromine, and iodine, not the row that you actually see here. And then finally, let's get to the noble gases. The noble gases are actually the helium, neon, argon, krypton, xenon, and radon located in group 8A. So as you see in this video, while we have the alkali earth metals and the alkaline earth metals have the label right over them, the halogens are actually the next group over with fluorine, chlorine, bromine, and iodine, while our noble gases are our helium, neon, argon, and krypton. I did not want to cover the atomic symbols with the names in this case, so that way you could see the important symbols of those groups. The halogens react very well with the alkali metals to form many of the salts that we'll see in this course. most notably that of sodium chloride. The noble gases historically are inert and will do some reactivity, mostly with fluorine, and you will see those in our molecular geometries chapter. The lanthanides are a special name, and that is the first row separate down at the bottom. It's actually supposed to be located right next to barium at element number 56. However, for ease in reading the periodic table, we will actually take out the lanthanides, and these get separated because they have a new orbital type that we will discuss once we get to our chapter on electronic properties. Below the lanthanides, we also have the actinides. These names come from the first element that falls into those groups. These contain f orbitals, and that is going to be one of their valence shells. So now that I've helped identify some important periods, groups, as well as specific group names, you have to be able to locate elements with just a little bit of context information. So let's identify the following elements on the periodic table with the correct symbol. The first one that we want to do is germanium. So if I go and look at the periodic table, that is going to be the element Ge. If I find cesium, remember that cesium is going to be in the alkali metals, so that is going to be Cs. If I try to find radon, remember we have to be careful because there's not only radon, but there's also radium. Which one do I have to look for when it comes to the R? Well, in this case, it is going to be our noble gas, so this is going to be Rn. If I look for cadmium, that is a transition metal. And if I do that, you will see that cadmium is Cd. Europium is actually a lanthanide metal. So now I have to look and see, but if you'll notice in the lanthanide metals, there's ER and EU. Which one is it? In this case, for our europium, we are going to have EU because ER is erbium. So now I have identified these elements. You have to work very diligently and be able to identify them very quickly, so that way you can get not only the right element, but possibly the right atomic mass. So now let's determine the answers for the following examples. Identify the elements with the following descriptions. An alkali metal in the third row. So now I have to look at the first column because those are the alkali metals, but then I have to find the third row or the third period. In this case, this would be the element of sodium. What is the heaviest lanthanide metal? Well, now I have to know where the lanthanide metals are. Remember, that is going to be that first row that is separated at the bottom of the periodic table. Then I must go all the way to the right to find the heaviest one, and that is going to be the element Lu, which we will commonly call lutetium. So now if I go to C, the halogen in the fourth row, that means I've got to go to group 7A. So I have to be thinking of fluorine, chlorine, and in the fourth row happens to be bromine. So this is going to be our element Br. So if I go to D, the only element in group 6 to start with a vowel, this means that I'm going to look for group 6, which is located just left of my halogens, and you will see that that starts with oxygen. Oxygen is the only one that starts with the vowels, so this is going to be the letter O. Now if we go to E and try to find an actinide named for a famous female scientist, well, you will see that that is the bottom row of the periodic table from our separated group. And as you scan some of the names, you will see one that is curium. This is named for Madame Curie. So curium is going to be our answer for letter E. Let us go and try one final example for today's second video. Which of the following elements could be considered a diatomic molecule in its elemental state? So this means that we are going to have an element that actually has two atoms in it based off of what we're used to seeing on the periodic table. So one way of looking at this and determining our diatomic molecules is that we have a list of them. This is going to be hydrogen, nitrogen, oxygen, and then we have to be very concerned about our halogens. So that is going to be fluorine, chlorine, bromine. So let us go and look at our group right now. Helium is not in this group, so helium does not count. Nitrogen, however, does show up in this group, so nitrogen is a possible answer of letter B. Beryllium is going to be an alkaline earth metal, and none of those are going to be diatomic, so that cannot be correct. And finally, when we have sodium, that is an alkali metal, it is monoatomic. It only wants to have one atom, so that is going to be incorrect. And seeing that we have at least one incorrect answer, E cannot be a choice. So B is the correct answer. As you're starting to go through and look at the periodic tables, you will become more familiar and more confident in remembering the diatomic atoms that make up their elemental state. In this video, you saw how the periodic table was organized, what valuable information you could get from it, as well as being able to identify your atoms and be able to select not only their periodic table name, their symbol, but also in the future, you'll be able to use their mass as well. Have a great day.